Okay, so we're doing lesson 4, factors and multiples. This is number sense 2 for math 15. So we're talking about factors and multiples. And factors are often grouped as pairs that can be multiplied to get a product. For example, the factors of 24 are 1 times 24, 2 times 12, 3 times 8, and 4 times 6. We would call these factor pairs. If we list out all those numbers individually, we're getting the factors of 24. So 24's factors are 1, 2, 3, 4, 6, 8, 12, and 24. Okay, so those are our factors if we're just listing the total number of factors. Multiples of a number would be the row for that number in a times table. So for example, if you're going 12 times 1, 12 times 2, 12 times 3, we get our multiples, okay? And multiples are pretty much infinite. So we can't often list all of the multiples because there's an infinite number of numbers that are going to keep coming up. But we could list a bunch of multiples. Now, a number that can be factored and written as a product of its prime factors, or a number can be factored and written as a product of its prime factors using only prime numbers. Now let's remember what prime numbers are. Prime numbers are numbers only divisible by 1 and itself. So if we're thinking of those, for example, we might have 2, 3, 5, not 4 because 4 also has 2 as a factor, not 6 because 6 has 3 and 2 as factors, but 7, not 8, not 9, not 10, but 11, not 12, but 13, not 14 because 2 and 7, not 15 because 3 and 5 are factors of 15, not 16 because 2, 4, 8 are factors of 16, but 17, etc. Okay, composite numbers are numbers that have more than 2 factors. So they can have 3, 4, etc. Okay, so for example, 4, 8, 9, I missed 6, but it's in there, 42, 56, all even numbers above 2 are going to be composite because they're all divisible by 2, 81, etc. Okay, so anything with more than 2 factors are going to be composite. So let's deal with multiples. So here it says, just to review, let's list the first 6 multiples of the given number. So the first 6 multiples of 3, 3 times 1. Oops, I don't like that pen for this. I want this pen. 3 times 1 is 3. That's the first. Then 3 times 2 is 6. Then 3 times 3 is 9. Okay? So that would be the first 6 multiples of, oh, sorry, that's the first 3. Goodness. Then 3 times 4 is 12. 3 times 5 is 15. And 3 times 6 is 18. Sorry about that. I misread that. I think I had 3 on the brain. For 4, let's look at 4. Again, 4 times 1 is 4, times 2 is 8, times 3 is 12, times 4 is 16, times 5 is 20, times 6 is 24. Okay? Then we're looking at 6. Again, we're just going through this list, right? 6 times 1 is 6, 6 times 2 is 12, 6 times 3 is 18. 6 times 4 is 24. 6 times 5 is 30. And 6 times 6 is 36. Nice perfect square there. Okay. Then 12. Woohoo! All right. 12 times 1 is 12. Times 2 is 24. Times 3 is 36. Times 4 is 48. Times 5 is 60. And times 7 is 72. Okay. So those are our first 6 multiples, okay? So think multiple, I'm going to have to be doing some multiplying, okay? If we're going the other way, we're looking at factors. So if we want to list the factors, we have to think of all the numbers that are divisible, that it's divisible by. And it's often convenient to list them by factor pairs. Okay, the first one is 1 times 12. Then we have 2 times 6. And then we have 3 times 4. Now, because we have 3 and 4 there, we know we don't have any more there. So those would be all of our factors. 1, 12, 2, 6, 3, and 4. For 18, 1 times 18, 2 times 9, 3 times 6. And then let's just think, is 18 divisible by 4? Well, let's try it. 18 divided by 4, I get 4.5, so it doesn't work. I also know 18 is not divisible by 5 because it doesn't end in a 5 or a 0. So then I'm wrapped around to 6, so I'm done. 24, it's going to have more factors, I think. 1 times 24, 2 times 12, 3 times 8, 4 times 6. Now 5 is not going to work because it's not divisible by 5 because it doesn't end in a 0 or a 1. So that would be it. 64. 1 times 64. 2 times 32. Now 64, 3 doesn't go into 64. A trick for if something's divisible by 3, if you add up the digits, if that number is divisible by 3, then it would be also divisible by 3. But 6 plus 4 equals 10, and 10 is not divisible by 3, so it doesn't work. 4, however, can go into it. It's 4 times 16. Let's try 6 just in case. I don't think it will work because it wasn't divisible by 3. So no, it doesn't. And 7 doesn't work. 5, of course, doesn't work because it doesn't end in a 5 or a 0. So I think we're left with 8 times 8, okay? And those would be all the factors of 64, okay? Now, normally, we are listing them by factor pairs. You can also just list those numbers. Now, sometimes we're asked to determine what's called the prime factorization of the numbers. And what we're going to do is write it as a product of primes. And I like to use a factor tree to do this. So we can use a factor tree to help us out. Okay, so the way this works is you just start by thinking of 2 factors of 24. Okay, I'm going to start with 6 and 4, right? Then I'm looking at each of those and I want to factor it down till I get to prime numbers. Well, 6 can be 2 times 3, and 2 and 3 are both prime numbers. So that's prime and that's prime. So if they hit a prime number, we're done that tree. 4, however, is 2 times 2. So we weren't done there. So 2 is a prime, oops, wrong pen. 2 is a prime number and 2 is a prime number. So if I'm listing this out as my primes, factor primes, it would be 24 is equal to 2, and I'm going to list them in order, times 2 times 2 times 3. That would be listing them as in their prime factorization form. Okay, so here these numbers are composite, so I'm not done, whereas these are prime. Okay, I want to get it so that they're all prime. So let's try the next one. Okay. I have 108. So I'm going to put it over here, 108. And I'm going to, 108, let's see, 108. I'm going to divide it by 9. And I'm lucky. it is divisible by 9. It's 9 times 12. Okay. Now, 9 and 12 are both composite. So if I factor those further, 9 is 3 times 3, and 12 is 3 times 4. Now, let's just look where we're at for prime numbers. 3 is a prime number, 3 is a prime number, 3 is a prime number. The 4, however, is not, so it can go down to 2 times 2. So now I've got all prime numbers, and I can list these. So 108 is equal to, I'm going to start with the smallest, 2 times 2 times 3 times 3 times 3. Now, remember we're doing squares. We can also write this as 2 squared times 3 cubed. Tricky, hey? But this will do, ladies and gentlemen. Okay? And now we have our last one here, 924. So let's think about it. 924, I think, 924, I'm going to try 12. Woohoo! I get 12 times 77. Okay. Now, 12 is going to be 3 times 4. 77 would be 7 times 11. So let's see where we're at for prime numbers. 3 is a prime number, 7 is a prime number, and 11 is prime number. However, 4 is not, so it can go down again to 2 times 2. Now, 2 and 2 are prime numbers, and I am done with this one. So this would be 924. Start with the smallest, 2 times 2 times 3 times 7 times 11. And that is my prime factorization. Okay? Factor trees are very convenient. They map it all out. Once you hit the prime numbers, you say, okay, that branch is finished. So find a way to circle it or highlight it. However, it's going to help you know that you're done. Okay? Now, we can use prime factorization of two numbers to find our greatest common factor. And a greatest common factor is, it is the largest number or the largest factor of two numbers. Okay, so what we do is we look at our prime factorization, and we're looking for right here, we're looking for the GCF of 20 and 28. So what we do is we find what's common to both. Okay, so here I have a 2 and a 2 in each. Then I have another 2 here and another 2 there. So I have, those are common to both of them. So they're going, but they're the only things common to both of them. I have a 5 and a 7, but they are not the same. So when I look at it, that means this and this are the same. So they will give me my GCF. I can also write them out expanded. So 20 is 2 times 2 times 5, and 28 is 2 times 2 times 7. The ones that are the same will produce my GCF. Okay, so these are the same and these are the same. So from this, I will get a GCF is equal to 2 times 2, which is equal to 4. So 4 is the largest number that goes into both of them. Okay, so 4 is my GCF. Okay. I can also use factor trees to find my lowest common multiple, but it's a little bit different because the multiple is bigger, right? So for here, I do look at what's common, right? But I also look at what's different, okay? Now, if it's common, I account for it once, okay? So my lowest common multiple will have from both 2 times 2, and then from each times 5 times 7. So my lowest common multiple of each of these is going to be equal to, where's my answer? Let's figure that out. 2 times 5 times 7. 140. So, and if I want to check that, make sure it is a multiple, I can go 140 divided by 20, and it goes in 7 times. And I go 140 divided by 28, and it goes in 5 times. Okay, that's the smallest number, they both divide into. Okay. Okay, alrighty. Now, so let's do some practice. And again, you can list this out like we did here. If you go 2 times 2 times 5, and then 28 is 2 times 2 times 7. So, and then you might look at it going, okay, well, I have this and this, but then I also have this and this. So that will give you your list, right? So it'll be 2 times 2 times 5 times 7. However you want to track that, okay? Alrighty, so let's keep doing practices. Okay, find the GCF and LCM of 42 and 56. So let's do a factor tree for each of these and find their prime factorization. So 42, we're going to go 6 times 7. 6 is also 2 times 3. And when I get there, that is my prime factorization, right? 2 times 3 times 7. Okay, now let's do the other one, 56. Well, 56 is 8 times 7. And 8 can be 4 times 2, which is 2 times 2. So if we look at our prime factorization here, we've got 2 times 2 times 2 times 7. Now, let's list them out on top of each other. 42 is 2 times 3 times 7. And 56 is 2 times 2 times 2 times 7. So, for our GCF, well, let's do some little accounting here. What's similar? Whoops. 2 and 7. Okay. So, for our GCF, it will just be those common numbers, right? It'll be 2 times 7, which is 14. For our LCM, well, yes, it'll be 2 times 7, but then it'll also be the other 3 factors, 2 times 2 times 3. So when we multiply those, we should get 168. Let's just double check that. Okay. 2 times 7 times 2 times 2 times 3, 168. Okay. So you can use the same work for both of those. And let it help you kind of sort out your LCF and your LCM and GCF. Okay, let's do another example because, I mean, the idea that we could learn it all in one example is kind of silly. So we're going to do our factor tree. So 180. 180 is, 9 times 10. No. Boy, that's silly, miss. 9 times 20. Right? Yeah, 9 times 20. So 9 would be 3 times 3, and 20 would be 5 times 4, and 4 can go down to 2 times 2. Now, let's just double check, make sure we got all primes. 3 is prime, 3 is prime, 5 is prime, 2 is prime, and 2 is prime. Okay? Now let's do the other one, 420. 420 would be, I think it's 20 times 21. I mean, you can use any two, but I think those work, and they do. 20 times 21. 20 is 4 times 5, and 21 is 3 times 7. 4 can go down again, 2 times 2. Okay, let's highlight our prime numbers, make sure we're there. 2 times 2 times 5 times 3 times 7. Now, let's list those out. Okay, so 180 is equal to, let's start by the smallest, 2 times 2 times 3 times 3 times 5. And 420, again, we're going to list them from smallest to largest, 2 times 2 times 3 times 5 times 7. Now, let's see what we got for matching. Okay, I have 2 and a 2, 2 and a 2, 3 and a 3, and a 5 and a 5. Alrighty, so for my GCF, it's what matches. 2 times 2 times 3 times 5, which equals 60 when I multiply that. And LCM, I've got to list this. And then I have a 5 left over, so let's not forget about those, right? Oh, sorry, a 3 left over and a 7 left over. So times 3 times 7, which equals, woohoo, 1260. So the lowest common multiple of 420 and 180 is 1260. But you can see, if we just did 420 times 180, it's a multiple of both of them, but it's huge. It's 75,600. So we want to find the lowest common multiple, okay? So you're going to do some practice with multiples and GCFs, and I got lots of worksheets. We're going to come back later in the class, and we'll go over some of these just to make sure we're getting it, okay? I know some people hate factor trees, but hey, do what you can.